Okay, today we are going to talk about two different types of sequences. Now, remember that a sequence is a series of numbers that follows a certain type of pattern. The first one is an arithmetic sequence. It's pronounced arithmetic, even though it looks like arithmetic. So an arithmetic sequence. It's an I here. For this sequence, I'm adding 3 to each number. Okay? That would be arithmetic. Remember, I'm adding a constant term for each thing. Okay, we call that term the common difference. So the common difference here is +3. It could be minus. Okay? Term 1 is 2. Term 2 is 5. Term 3 is 8. Term 4 is 11. 4. I'm not writing this correctly. Term 4 is 11. And term 5 is 14. Okay. I can graph this. Now, for these, I really only need the first quadrant. The x-axis goes the terms. On the y-axis goes the values. Okay, so my point here, I'm just going to graph the points. This is going to be a discrete graph. Remember, discrete as dots is 1, 2. 1, 2. Go over 1 up 2. 2, 5. Go 2 horizontally over 2 and up to 5. 3, 8. 4, 11. 5, 14. This is part of the linear function. So all of my arithmetic sequences are going to be linear. I'm going to do another one here in blue. So my common difference for this one is -2. My common difference on my first one was +3. Okay. I can make a term versus value chart. 1 goes with 17. 2 goes with 15. 3 goes with 13, 4, 11. I'm going to plot these points. 117 starts up here. 215. Still a linear function. This is still part of the linear, but now this is a decreasing linear function versus my red one here. My first one was an increasing. Okay? So that is type 1, arithmetic sequence. Okay? It is a sequence. In a couple of years, you'll learn what a series is. It's not a series. This is a sequence. Okay? There is a difference. Please do not mistake those. A geometric sequence, instead of adding a common thing, there are other patterns that you can find too. They don't all have to be arithmetic or geometric, but for now, we're going to start with these two, okay? We will learn how to write formulas for them. A geometric sequence Each one of these I am tripling or multiplying by 3. Instead of a common difference, I have a common ratio. Okay, and that ratio is what I multiply by. Multiplying by 3 for this one. Again, the term, oops, the first term is 2. So term 1, 2, 3, and 4. I've only listed 4 of them. Nope. The first term is 2. The second term is 6. The third term is 18. And the fourth term is 54. When I make my graph of this, 2, 3, 4, I'm going to number by 5s here because I got a long ways to go. Not sure why I'm labeling everyone. 15, 20, 25, 30, 35, 40. So because I'm getting up to 54, I'm labeling each one by 5s because otherwise I don't want to put 54 dashes. So 1, 2, no, that doesn't get all the way to 5. I'm just going to go, that's 2/5 of the way there. I'm going to go approximately 2/5. These won't be perfect. 2, 6, 3, 18, 4, 54. This is not linear growth. This is a discrete exponential curve. So the geometric sequences are part of the exponential family. Okay. Common ratios are not always increasing. This sequence looks like I'm dividing by 2. So my common ratio is actually 1/2. Dividing by 2 is the same as multiplying by 1/2. So I'm going to call my common ratio because common ratio is always multiplying, so I have to use the multiplying one. Divide by 2 equals multiply by 1/2. This is still exponential, although this is a going down exponential, or what you're going to learn to eventually call exponential decay. Okay, still exponential. Geometric sequences are always part of the exponential family. Arithmetic ones are always part of the linear family of functions. Okay, so for your work, make sure you're classifying it, find the pattern. It will be either arithmetic or geometric, and then you're going to have to match the graph by literally putting the points down. The points all match on the graphs that they have. Okay, that is your lesson for today.